Okay, so let's continue here. This section is asking us to talk about function notation. And what we're going to do now is instead of always saying y equals, we would like to change to f of x. And so what that means is we have a function f and of x, you see here in parentheses, which just means we're plugging numbers in for that x. So I've seen a lot of people look at that and say, oh, that's f times x, and they try to multiply. It's very confusing. It just means plug the number in that's right there. Okay? So f of x, it's a function of x. All right, so they're going to ask us here to change the equation y equals 2x squared minus 5 into f of x equals 2x squared minus 5, and then evaluate it for certain values. So notice that if x equals 3 and we want to evaluate f of x, it becomes f of 3. And that just means everywhere you see an x, plug in a 3. Same as it did before, we're just writing it a little different. Okay, so 3 squared, that's going to be 9. And then 2 times 9 is 18. Minus 5. And that's going to give us 13. Okay. Then they ask us to plug in -1. So f of -1, that's 2 times -1 squared minus 5. -1 squared is -1 times -1, or +1. So it's really this. And 2 times 1 is 2. 2 minus 5 is -3. So not too bad. We're just plugging the numbers in and trudging through some arithmetic. This last one here is when x equals 0. So f of 0 would be 2 times 0 squared minus 5. 0 squared still 0. So 2 times 0 is also 0. And so you'll see me do this notation quite a lot. I'll put an arrow through and say 0, meaning that whole term, when combined, goes to 0. So this would be 0 minus 5, or -5. Okay. So that's the simplest thing that we'll do, or the most simple, I guess I should say, plugging in numbers into a function. We can also plug in other functions or other variables into the original function. And these are going to be called composite functions. So I notice there's a little discrepancy here. Let's just fix this. Let's make this plus, I suppose, since it's plus down there. Okay. All right, so I have the function g of x equals 4x minus x squared. And I would like to plug in -x, which again means anywhere I see an x from before, I'm going to put a set of parentheses. And inside of those parentheses, I'm plugging in a -x. Okay. Then I have to perform whatever the operation is. So here I have 4 times a -x. That's -4x. Minus. Now I have -x in parentheses squared. Remember, PEMDAS says to do the exponent next. That's really -x times -x, which is x squared. Okay. And then finally, we just distribute or apply the negative there. So that's minus x squared. So -4x minus x squared is what we end up with. Okay. Now, if we get to talk about even and odd functions, we'll bring this back up later, just as a reminder. All right, now let's plug in x plus 2. Okay, so the original function was 4 times, let's say, parenthesis, minus a parenthesis squared. And this time we're plugging in x plus 2 into each one of these. Okay. So for this first part, I actually have to distribute the 4 inside. So that's 4x plus 8. Over here, I have x plus 2 squared. So that's x plus 2 times x plus 2. So let's do FOIL, and then I can show you a shorthand way to do this. So x times x, that's x squared. X times 2, that's 2x. 2 times x, also 2x. And 2 times 2, which is 4. So remember, FOIL is first, outer, inner, last. So that's what I did there. Then I would combine the terms in the middle, the 2x plus 2x combined to be 4x, and I'm left with this. Shorthand, I'll just quickly show you. If I have anything a plus b squared, it's the first term squared plus 2 times the first term times the second term plus the last term squared. And if it were minus in the middle, then the only difference is you get a minus there. Okay. So if you wanted, you could do this shorthand, right? It's x plus 2 squared. You do the first thing squared, 2 times the 2 terms, which is x and 2, and then the last thing squared. So that's x squared plus 4x plus 4. So just a different way of doing it. If you don't like that yet or don't quite understand it, please stick with FOIL. I just like to give you more things and maybe you might need right off the bat, trying to strengthen your skills. Okay, so let's replace the x plus 2 squared. And again, I'm going to leave it in the parentheses because that negative has to be distributed to everything. So it's probably best to think this is a -1 that I'm going to multiply each of these by. So this becomes 4x plus 8 minus x squared minus 4x minus 4, right? Because -1 times anything makes that thing negative. Then I notice I have 4x and -4x. Those completely cancel. And then I have plus 8 and minus 4. So adding those two together, I get 4. So I'm left with minus x squared plus 4, or if you prefer, 4 minus x squared. Now I'm going to encourage that you write it this way. This is called descending order. So that's powers of x's and down from the highest power to the lowest power. So I would encourage you to write it that way. Okay. We have another example here. They give us a function h, which is a square root function. They tell us to plug in 3 and then plug in -x. And finally, let x go to x plus 1. Okay. So h of 3 just means plug 3 into this equation. So I have square root 3 squared minus 1. That's square root of 9 minus 1, or square root of 8. You could technically stop there, but it's not a good place to stop. Right, square root of 8 is 4 times 2. If you'd rather, you can split that into 2 parts. And so square root of 4, right, is 2. So it should be written as 2 root 2. That's the best way to put it. So that's just plugging a number in. What if we plugged in a -x? What happens to this function? Okay, so again, I'm going to put a set of parentheses wherever I see an x. And inside that set of parentheses, I am plugging in -x. Well, negative x squared is just negative x times negative x, or it gives me back x squared. So actually, I get the exact same thing as the original function. And as I said, later on, we'll talk about this. This is actually going to be called an even function. So if you want, you can go look that up. If not, probably just kind of put that in the back of your mind that later that we might want to use that little trick. Okay. Last one says plug in x plus 1. Okay. So remember that h of x was the square root of something squared and then minus 1. And the something we're plugging in this time is x plus 1. So again, if you like, let's FOIL that. So first is x squared, outer is x, inner is also x, and last is 1. So that's x squared plus 2x plus 1. I'm going to plug that back in here. And because of the fact that this is all positive and there's no negative in front of the set of parentheses, I can drop the parentheses. And notice that the plus 1 and minus 1 completely cancel one another. So I am left with the square root of x squared plus 2x. Okay. So those are some examples of plugging different values into functions. We'll continue next with the vertical line test.